Let's do a video here about the shape of this graph and the slope of this graph. So this is what you might get if you took the data for the light bulb, right? And notice that the graph is steep here and it's not so steep there, right? The fact that this is not a straight line, the fact that it doesn't lie upon this line right here, okay, means that this does not obey Ohm's law. Because if it obeyed Ohm's law, right, it would be Ohm's law is that R is what, V over I, right? So I should be 1 over R times V, right? Plus 0, right? So this is our slope. Our slope is 1 over R, right? Let's see if I can zoom in on that. There we go. Okay, our slope is 1 over R. This is like our X. This is like our Y on this graph, right? And it should have a 0 Y-intercept, right? And if you look at this graph, look at that graph, right? You can see it, you know, the first part here definitely has a 0 Y-intercept or something like that. But the slope starts to change, right? Now, what's happening here is that this is, of course, a light bulb, right? Okay, and light bulbs get hot, right? So in this region here, it's getting hot, and the resistivity is changing. In fact, the resistivity to make this line like this, the resistivity actually has to increase at some rate. Okay, it's not that it just changes here and stays constant. It actually has to keep increasing to make it do that. And that's what it's doing because the temperature is going up. Okay. Anyway, that's the basic idea behind Ohm's law, and the fact that this thing doesn't have a 0 Y-intercept, the fact that the slope changes, right, means that this is not true. Okay, this graph should look like this. It should go through 0. The slope shouldn't change like it did there, right? Okay, that's the basic concept.